Hi, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled Emerging Stormwater Technologies in Rhode Island, Cultec Separator Rhode and StormTech Isolator Rhode Plus, brought to you by the Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be assisting with logistics for today's program along with Avery Davis from the Syracuse University Environmental Finance Center. Before we get started, I'd like to say a few words about the SNEP Network. The SNEP Network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you want to learn more, please visit our website, snepnetwork.org, for more information. And before the webinar begins, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. You will be able to ask questions by typing them into the questions box on your GoToWebinar control panel. We look forward to answering questions, so please type them in at any time. We also have closed captions available for today's webinar. To view the closed captions, please click the link that we will put into the chat. And on that note, I'd like to hand things over to Rebecca Reeves, who will provide us with some background information and introduce our speakers for today's webinar.
Thanks so much, Leah, and welcome to all of our attendees. If you are not familiar with the Stormwater Innovation Center, we are an organization that is part of the Audubon Society of Rhode Island, and we are mostly based out of Providence, Rhode Island, although we do work all over the state to relay the importance of green infrastructure to mitigate water quality issues. And we do this through a few ways, as you can see on our screen. Monitoring, training, community engagement, and collaboration are our focuses. Just to give a few examples of some fun things that we do, on your upper left hand of the screen, you'll see some of the Stormwater in Schools programming that we do here in Providence and Cranston Public Schools for students to learn about how stormwater functions and how green infrastructure functions. On the upper right side of the screen, we have one of our Brown University interns from last summer doing some water quality monitoring in Roger Williams Park. And we also have a photo on the lower left side of our stormwater director, Ryan Kopp, doing a tour of some green infrastructure within Roger Williams Park that the city of Providence has installed. We also hold some community events to help engage the public around these issues. So one of those ways is through our Fall Festival, which is a family-friendly event held in Roger Williams Park as well. The middle lower picture is from that festival. And then on the right side, we have a student who painted some rain barrels for us that were then raffled off to the public. So we do a lot of work in the community to try to raise awareness about these issues. You can head to the next slide. So today we will be focusing on two newly approved pre-treatment stormwater technology devices. They were recently approved by Rhode Island DEM. And we will have representatives from both of the companies who manufacture these products, Aaron Cheever from ADS and Kyle Smiley from Cultec, to talk about their respective experiences. And then we have Brian Giroux from Dupree. He has experience working with these technologies, actually getting them implemented. But first we will hear from Christopher Dill from Rhode Island DEM. If you're interested in full bios for any of our presenters, you can find them at a link that is listed on the slide, and I will also put this in the chat. You'll also be able to find a full recording of this presentation within a few days at that same link. And without further ado, I will hand it over to Chris Dill.
Hello, everyone. My name is Christopher Dill. I'm an engineer in the Stormwater Construction Permitting Program at the Rhode Island DEM. I'm the primary contact for our proprietary stormwater treatment technologies program. And basically, we collaborate with between DEM, Rhode Island DOT, and the Coastal Resources Marine Conservancy Service to approve these technologies and review them for use in Rhode Island. Next slide, please. So yeah, like I said, there's DOT, DEM, and CRMC. From CRMC, there's Ross Singer, DOT, Elisa Richardson, the administrator of the environmental division. And then at DEM, there's Eric Beck, the administrator of groundwater and freshwater wetlands. Then my supervisor of the stormwater program, Nick Pisani, and then myself. And right there is my contact information if you need to reach out to me for any reason regarding the proprietary stormwater technologies. And I believe these slides will be going out to everyone afterwards, so you'll have access to that. Next slide. And in Rhode Island, currently with our technology program, there are 3 different levels of certification: retrofit, pre-treatment, and water quality BMP. So retrofits, that's basically just an old site that really didn't have much for stormwater management to begin with, or it's just been a neglected system. So it's kind of just trying to revamp the site and kind of help improve the water quality. The standards are a little bit more lax there. Pre-treatment, basically used to protect the water quality BMPs, reduce the sediment load getting into there to help slow them down from clogging, and kind of concentrate the maintenance. Pre-treatment devices can also be used as retrofit devices. And then also there's the highest level, which is the water quality BMP. So that would be essentially on par with like a infiltration basin or a sand filter, something like that. And but today we're going to be focusing on pre-treatment for the isolator and separator rows. That's what they're both about to be approved for in Rhode Island. And they'll also be approved as retrofits. So next slide, please. So this is just a little flow chart of the process for how we approve devices. Basically, the vendor gets testing, they submit an application to our program, we review it, and then we'll evaluate what they submit, make requests for additional information if necessary, and then once all the criteria has been satisfied, we finalize the certification, issue it, and then hold trainings like we are today. So next slide. And part of the criteria that we use, it's codified in our regulations for these proprietary devices. We offer reciprocity in Rhode Island for devices that have either TAPE or TARP approval. You can see the definitions of those acronyms at the bottom of the slide. And basically TAPE is the Washington program. TARP is a consortium of states. The program's kind of faded out, but we still allow reciprocity for states that were a part of those programs. And for the isolator and separator rows, the isolator row has a New Jersey, it's the NJCAT approval. They don't actually have the New Jersey Department of Environmental Protection approval yet, but that's because of more of a formality. So we're allowing reciprocity in that respect. The separator row is in the process of getting that NJCAT verification, and they also supplied us with a Enviro technology verification as well. So that's what we've kind of been using in the interim for that one, and we're hoping to see their NJCAT approval in the next few months. Next slide, please. And then the certifications are good for 5 years, and at that point the vendors have to submit a reapplication and make sure that they're reporting any system failures or anything like that, and then also letting us know about any new studies or revoked certifications that they may have had. And if you could actually just go back to the last slide for a second, please. So with the reciprocity also, we've in Rhode Island, we've historically allowed the use of both of these pre-treatment rows. So it was just kind of about time to get them into a actual certification. And another state that also allows their use is Massachusetts, which is part of that TARP program. So if you go ahead 2 slides now, please. And And if you click on that link in this slide, well, so if you go to the link and then click on the stormwater analysis and design guidance documents dropdown, the fourth item will say stormwater proprietary technologies list and application form. So that will show you all of the technologies that we currently have approved. The isolator and separator row are about to be uploaded onto that list very soon. And once we get those two uploaded, we will have currently, since we rebooted this technology program in 2021, we will have approved 4 water quality BMPs, 10 pre-treatment devices, and 1 retrofit device. So next slide, please. So yeah, that's about it. So like I said, there's my contact information if you'd like to reach out if you have any questions about how to design these devices in Rhode Island. So thank you very much. And I believe we will now be turning it over to Kyle Smiley with Cultec.
Good morning, everyone. Thanks for joining us. As you heard Chris say, the Cultec Separator has been approved as a pretreatment device, providing at least 25% suspended solids removal. This is a rendering of a typical Cultec system, and you can see the components of our underground chamber system on the far left row. You'll see a chamber row that looks like it's wrapped in a fabric. That would be the separator row. And what that would look like from a plan view would be a row of chambers with a layer of our woven geotextile fabric rolled out beneath the entire row. And the hatching would represent a layer of non-woven geotextile fabric going around the chamber. Some other components of a separator row would be, you would want an inlet structure kind of lined up with the separator row shown in this plan view to be able to maintain the system, and some sort of bypass pipe to go into the adjacent separator row once that water quality flow is collected. This is a side cross-sectional view of a separator row. With that inlet structure, you can see we want at least a 24-inch sump going into the separator row, and that's part of the approval document Rhode Island is providing. Some other components you'll see: an inspection port. That's essentially a port that you could look in and monitor how much sediment has collected in the system. And an end cross-sectional view again shows where a separator row could be located in the system. And for each chamber model, you can find a cut sheet on our website that'll show chamber spacing, chamber size, and how much minimum cover is required for traffic applications. As part of the approval, we have flow rates for each chamber model that can be used to design and size a separator row. The highlighted column, maximum treatment flow rate per chamber. Essentially, you would take your water quality flow in cubic feet per second and divide that by one of these values, depending on which chamber model you're using, and that will help you determine how many chambers you need in your separator row. So as long as your separator row has at least as many chambers as your water quality flow is telling you, you shouldn't have any issues with any system backup. You know the water going in to the row is going to be outflowing faster than, for your water quality flow, outflowing faster to the fabric than is required. Maintenance access piping. So maintenance is probably one of the biggest things about these separator rows. If they're not properly maintained, they won't function properly and you won't achieve the flow rates specified in our flow rate table. So for each chamber model, depending on size, we do have a recommended pipe size for maintenance. Typically, that's going to be the largest pipe size that the chamber allows into the end cap. On the right side, you can see the 360 HD chamber has a maximum 24-inch HDE pipe into the end cap. So that's what we would recommend for maintenance access piping. And you can find this information on our website under there's a products drop-down list, and you can download our cut sheets for each chamber model and find what the max inlet pipe is into the end cap. But you can also download the presentation after and use this slide as a reference point as well. Some things to not do with access piping, and these are kind of things I've caught over the years of reviewing separator row systems. The biggest is we do not want an outlet on the separator row. I have seen that a few times. When you're putting water into the separator row with sediment, you don't want that water going back out. It sounds simple, but I have seen it in the past. We do allow side port entry into our chambers. But a problem with doing that on a separator row is, again, you can't maintain the system that way. So this screenshot is kind of an example of side port access, but how do you backflush the separator row? You can't really do that when it's coming in at a 90-degree angle. And then no feed connectors on non-treatment rows. So we do have an internal manifold system called feed connectors, kind of similar to outlet piping. Once you put water into the separator row, you do not want it coming out anywhere except through the filter fabric. For the bypass piping, each chamber model, we will recommend a bypass pipe size. Again, kind of based on the chamber model and what kind of pipe that chamber model allows into the end cap. And the bypass piping is our recommended method for bypassing the separator row during flows greater than your water quality flow. And for the elevated bypass pipe, you can see in the rendering here, coming out a little bit higher out of the catch basin into the adjacent row. We recommend that be at least a 9-inch raised invert, just so you can allow that driving head into the filter fabric in the separator row. There's a couple of other methods you could use to bypass water from the separator row. You could have a diversion weir in your structure, upstream structure, or a crown match T fitting, which we would probably recommend a crown match T if the inlet structure is far away from the separator row. You can reduce the linear feet of piping on your project, but again, recommended method is elevated bypass pipe. Inspection ports. We get this question a lot. Where do I put an inspection port on a separator row? Our go-to location would be at the end of the separator row. That way, you can kind of monitor the system from the inlet structure, and then at the very tail end of the system of the separator row, you can look inside and see how much sediment has collected. If the separator row exceeds 200 feet, we recommend you add additional ports at a maximum 200-foot spacing. So if you have a row that's 400 feet long, you'd want 3 inspection ports. 200 feet long, you'd want 2 inspection ports. Anything less than 200 feet, 1 inspection port is fine at the end of the row. Feed connectors on separator rows. This is a project we completed recently up in Maine. We do allow feed connectors on separator rows as long as they're connected to other separator rows. But when you do that, you can see here, we do want additional maintenance structures to be able to maintain those additional separator rows. Maintenance. Per the approval through Rhode Island, these systems need to be inspected at least twice per year. And when the sediment exceeds 3 inches as observed through the inspection port, that's when we would recommend the system be back flushed with a jet vac. This is a little screenshot of our operation and maintenance manual for separator rows. It can be found on our Cultec website, or you can contact me directly and I can send it over to you. This is just an example of the jet vac process. Typical vacuum truck with a sewer jet, they'll attach a nozzle that you see in the bottom right to a fire hose and blast it through the chamber row. And what that does is flush all the sediment back into that upstream manhole with a 24-inch sump, and they'll stick the vacuum hose right into the structure and remove all the sediment into the vacuum truck. Just a good aerial view of a separator row. This is a project down in South Carolina. You can see the contractor has laid out the woven geotextile fabric all the way down the separator row. So they're pretty easy to install. These systems do not really add much project costs at all. All it is a roll of fabric added. And you can see here, the contractor has the inlet structure laid out in line with the separator row for easy maintenance. And that's all I brought for you. This is my direct cell phone number. If you have any questions, please feel free to text me or call me, or you can email me and I can send you any documentation that you're looking for.
All right, thank you, Kyle. And I believe now we'll be turning it over to Aaron Cheever with ADS.
All right. Thank you very much. Aaron Cheever with ADS and StormTech here. We're going to talk about the StormTech Isolator Row Plus, so let's dive in. First and foremost at ADS, our promise is to protect and manage water, the world's most precious resource, safeguarding our environment and communities. So how do we do that at ADS? We do that by making sure that our product portfolio has stormwater solutions to support the life cycle of a raindrop. Specifically, therefore, you need to have options to capture stormwater, convey it, store it, and treat it. So with that, today our focus is going to be storing and pre-treatment with StormTech. Quick overview for those of you that probably already know this, but let's talk surface versus subsurface stormwater management first and foremost. Surface is kind of obvious. Take a hole, convey your stormwater to it, store it, draw down over time. What's that ultimately do for your site though? It's an inefficient use of space. It limits the overall development, and it could potentially be a safety hazard for the owner. Subsurface stormwater management, on the other hand, you're able to maximize the development, provide more parking, and possibly fit things into a tighter right of way. So that's what you're focusing on when you're looking at using a subsurface solution versus a surface. Here's a lovely example of that. We have a nice new college dormitory that was built next to that scenic detention pond, unusable land. That dormitory obviously has a necessary parking demand that needed to be met. So the best way to do that, convert the pond to a chamber system, subsurface option. Now underneath the parking lot, buildings meet the parking demand. Meet the chambers. This is the StormTech chamber family, including the newest one, the SC800. All StormTech chambers are manufactured to the ASTM standards F2418 and F2922. Those are specifically the material standards. And then all StormTech chambers conform to the design requirements of ASTM F2787. What that does is it ensures chamber quality and a safe structural design, adding factors of safety to our chambers and confirming their long-term performance and arch stiffness and other features. But we're talking isolator row and pre-treatment BMPs, so that's my 100,000 foot view of StormTech. But let's get into the isolator row. The StormTech Isolator Row, well over 20 years old now, was your original BMP that could be built into your chamber system. The Isolator Row was patented many years ago. When the patent ran out, other manufacturers were able to kind of dovetail their way in and follow StormTech's lead. What the Isolator Row was, it's a dual layer of woven geotextile on the bottom between the base stone and chamber feet, and then there was a non-woven geotextile placed over the top. The reason for the non-woven geotextile back in the day was ultimately because the SC310 and SC740 chambers, which were the original two, they were perforated along the bottom. So the sole reason for that non-woven was to trap and isolate sediment within the isolator row and not let it travel horizontally outside of the chamber row. So to that end, as we get into things more, now that the perforations are no longer there, if you don't want the non-woven over the top, from our perspective, it's no longer needed. And then likewise, the reason for the dual layer of geotextile on the bottom is so that when you maintain it with a jet vac, you have that factor of safety built in case the geotextile were to potentially rip, you have a dual layer there. This is how the isolator row works. So first and foremost, you have to have your lovely storm. You're gonna have your life cycle of a raindrop. You're gonna capture it, you're gonna convey it, and now it's time to store. Your inlet water is gonna come in to your isolator row. The isolator row is sized for your water quality event. And at that point, the entering stormwater is gonna go down through the dual layer of geotextile and into the base stone. At that point, what happens is the perk rate of the subbase material is going to be the restrictive feature, and your footprint is actually becomes saturated as the water travels through the base stone. So more often than not, these systems are actually acting as bathtubs. But when those larger storm events happen, there's going to be the need to potentially bypass to the other rows. And similarly, to make sure you're getting that driving head through the geotextile, you want to make sure that you're setting your weir elevation, or when I'm about to talk elevated bypass manifold, to a minimum elevation of 9 inches above your chamber base. As I alluded to, there's another way to do this. So weirs in your access structure, that's totally fine, totally feasible. But at times during maintenance, a weir can become a hindrance. I'm 6'2", 240 pounds. If I jump into a manhole and there's a weir in there, probably going to be a tight fit. No weir, much more easier for me to access. So looking at this right now, you have your isolator row, you get your 2-foot depth of sump. Water is going to come into your isolator row at the bottom connection. And then this is set up for your elevated bypass. So the elevated bypass has now created a weir without having a weir in it. And all of our chambers, for that matter, have these typical dimensions for what we refer to as the B dimension here, which is a top connection end cap, or the C for a bottom connection end cap. So every chamber has these for the standard sizes and their various pipe diameters that the pipes can fit in. Just know that as long as you're hitting between those two numbers, great. If you're going below or above, not so great. So keep that in mind during your design. The stormwater isolator row is tested at the UNH Stormwater Center. This was held as gospel for many years in New England. At that time, specifically, its TSS median removal rate was 80%, as well as some other removals that they were able to target at that time during the study. Looking at that sizing back in the day, this is how it proved itself out. Specifically, the performance claim certification at the time was 80% TSS removal achieved by sizing the isolator row or rows to treat the water quality flow at a specific flow rate, not to exceed 2.5 gallons per minute of bottom area, using 2 layers of ADS geosynthetic 315 WTK or approved woven equal. And so as you can see here with a 2.5 gallon per minute per square foot loading rate on the left, you can then see the flow per model that you get with each chamber in your row. So let's size an isolator row, shall we? I want to use the SC740 and my water quality flow is 1.5 CFS. So in order to have an adequately sized isolator row at that point, I'm going to need 10 SC740s within my isolator row or rows. As I alluded to though, StormTech Isolator row has been around for more than 20 years. The patent ran out. So when imitation occurs, you got to get involved with innovation. So with that, now we have the StormTech Isolator Row Plus. What is the StormTech Isolator Row Plus, Aaron? Well, the StormTech Isolator Row Plus is now a single layer of the ADS plus woven geotextile that's placed between the base stone and chamber feet. And then it also has the new feature known as the flared end ramp, AKA the flamp, which is at your inlet to the Isolator Row Plus. What that does is allows for nice, easy flow distribution, as well as provides a nice ramp for your maintenance contractor. And you can see here in the bottom right corner, these are the recommended type of nozzles that one should use when maintaining an Isolator Row Plus, using a twin floor cleaner or a floor cleaner jet. Those are more ideal. Using the pipe cleaner nozzle head, that's a bit of a challenge. I know the Isolator Row example I gave earlier showed that, but using that's a bit of a challenge when you have that 3 inches of sediment buildup that needs to be maintained. It becomes a big nuisance for the maintenance contractor. So you really want to make sure you're using the proper nozzles when maintaining. As talked about earlier in the presentation, the StormTech Isolator Row Plus is NJCAT certified. And then again, the new woven ADS Plus geotextile only requires a single layer. It requires only a single layer between the base stone and chamber feet because it ultimately has higher tear resistance, so you don't need that factor of safety. And it also has a much higher flow through capability than the previous option. And so showing that forward, the Isolator Row Plus sizing now uses 4.1 gallon per minute per square foot per model. And your flow per model, you can now see on the right-hand side in the green, the increase that each chamber now gets using the Isolator Row Plus in lieu of the OG Isolator Row, the original Isolator Row. So stepping forward, let's size an Isolator Row Plus, shall we? Again, we're going to use SC740s. with a water quality flow of 1.5 CFS, now using 0.26 CFS per chamber. You only need 5.8 chambers per isolator row plus. So basically you're going to have 6 chambers in your row for a minimum to meet it. StormTech Isolator row plus maintenance. As you can see, when the chambers getting installed, your geotextile, your wovens, it's fantastic, nice and new. Over time though, it's going to get dirty. You're going to bring in your jet vac, stage your vector at the access manhole, and then in the end, it's going to be back clean, back to day one, ready to go. Here's lovely pictures of before and after cleaning of the isolator row. You can see these nice clear rows, no repeating end walls or anything to that nature. Nice, easy access for the maintenance contractor. One other item to keep in mind is long rows. If your isolator row gets between 175 to 200 feet, you probably want access at the other end. Reason being, again, thinking of the maintenance contractor, it's very hard to pull these jet nozzles when the row exceeds 200 feet. So keep that in mind. If you have a 400 foot long row, you might want to consider breaking it up midway, having a structure midpoint along the way so that maintenance can be done more easily by the maintenance contractor. And just some real world examples and things to think about. The importance of construction sediment control. You can see this project ongoing. Oh, no inlet protection at the catch basin they put in. What's that mean? The system's online before it should be. So as you can see here during post construction inspection, before they're about to turn it over, there was already a large sediment built up on the woven geotextile prior to paving. All good. Isolator rows there. Contractor can get in, get it maintained. Looking at the other row, the outlet structure, you can see at the far end, the elevated bypass manifold into said row. And there you go. Because of the presence of the isolator row, all the stone, the clean crushed angular stone that you're taking 40% volumetric credit for, all clean, no sediment. It's all isolated within the isolator row. And then lastly, a real world example here that we should all focus on, the importance of construction sediment control at its highest. This is at Lake White Commons, Shrewsbury, Massachusetts, if you're not familiar with it. The contractor didn't have the greatest idea of where to clean out the concrete trucks. Well, guess what ended up in the isolator row? The slurry. But again, the systems had isolator rows, so they're able to get in there, do a whole lot of maintenance, get these things clean. But luckily, the isolator row was in place, and they didn't have to completely rip these systems out of the ground. So that's it in a nutshell there. StormTech and the isolator row, and now the isolator row plus. And at that point, thank you everyone for your time. Contact information is right there. Cell phone, email, reach out if needed. Thank you all for your time.
Thank you so much, Aaron. I think we're going to turn it over to Brian at Giroux now from Dupree Engineering. And just a reminder, you can type your questions in the chat. We will get to those after this last presentation. Brian, I don't think we can hear you.
I just did a whole intro by myself. Thank you. You think I'd be used to that by now. Good morning. My name is Brian Giroux. I'm a principal here at Dupree Engineering. We're a site civil firm. We focus on a lot of private developments, a lot of different jobs, and we use this technology a lot. And the big thing is we work with our engineers in-house, we work with our clients, we work with our regulators to really get the best BMPs we can for any site. Every site's different, so we do what we can to get the best out of everything. So why do we use it? And it comes down to a lot what Aaron and Kyle were just saying. Maintenance, maintenance, maintenance. What is the common cause of BMP failure? Poor maintenance. What can result in unexpected flooding? Poor maintenance. What can cost an owner a lot of money? Poor maintenance. The isolator row and the separator row are means of efficiently and easily maintaining the BMP system, providing TSS removal and protecting the overall health. Aaron has some great photos there of showing what happens when you get a system that gets clogged up with sediment. The other rows are maintained and they're easily still usable. The maintenance row took all the damage from the storms. I think everyone's aware we've had a lot of storms already this year. I think we've had 7 storms over 1 inch. So what I like about the separator row and the isolator row is that we are having a system that takes storm after storm. They got the 1 inch of runoff, storm after storm. That is what takes the sediment. And we have these other rows that are more or less pristine, that when these big storms come in, we have something that can handle these large flood events that we are getting way too frequently, it seems like these days. So design, going into this side. Until now, we haven't had the opportunity to just use the isolator straight up with the RISDISM and Rhode Island Stormwater. So big thanks to Chris and his team for working to get new technologies on the approved list here. Previously, what we did was we had a hydrodynamic separator, some sort of upstream proprietary device that would take out the sediments, and we wouldn't have a need per se for the isolator, but we still used it. And that came back to the main thing of trying to protect the system. What can we do to make sure that these systems are viable when that large storm event comes in? What can we make sure to do that the client doesn't have to dig up a parking lot later, shut down their business because we have a system that's failed? We want to avoid that as much as we can. So let's talk about a couple different case studies here. I have 3 to talk about, and when I was going through our different projects, I was trying to find some simple cases. Nothing simple with any of the sites that we do these days. So each one is unique as everything we do. So on this site here, we have the isolator row up on the left side, and this is just actually a water quality system. So this was a redevelopment site, didn't require peak mitigation, but we did have to do water quality to meet the requirements of the RISDISM. In doing so, we have a bypass manhole here that is just for peak mitigation. So we have the water quality flow is going to come in, peak mitigation is going to go out to the connection in the street. We had a pre-treatment device. As noted, since we didn't have this on the approved technology list, we had to do something to meet the requirements of DEM, and that was handled with a hydrodynamic separator in this case. Then we have a maintenance manhole. As shown by Kyle and Aaron, having an ability to get in and maintain this row is critical. We handle the peak flow bypass by doing elevated pipes. So we would have this entrance into the isolator row at the bottom, and then going into the other chambers, we would actually come into the top. That would provide that difference as required. And then lastly, because we had a roof row coming into this, instead of putting this through the isolator row and also a hydrodynamic separator, we had that come into an inlet on the side of the chambers. Essentially it's roof, no sediment, kind of keep it out of the mix and let that just go right into the other chambers. Next case study I want to talk about was a system that does have a QP system. So it has the peak system, large system down here, but this particular site had a very high infiltration rate. And as such, per the Rhode Island Stormwater Manual, we're required to slow down the infiltrating into the soils because of how quick it goes in. So we did 2 separate water quality systems. Just the way the site worked out, we had to approach it from 2 different sides, and each of them has their own isolator rows. So they have an isolator row for pre-treatment on either side, and then the water quality systems on top. Both sides had, once again, a bypass manhole for the peak. So the peak storms were going into the other chambers. We had a pre-treatment device, which once again was a hydrodynamic separator of sorts. Maintenance manholes, need to have a way to get in and maintain these guys. And then we use the separation on the difference between the pipes going in and out of the chambers to allow us to get water from separating from the isolator row to the other section of the water quality. The beauty of these types of systems is the flexibility it allows. So here we have completely different than the previous case, doing different sections of isolator rows, different sections of water quality, and we're all able to do this in any sort of makeup. And yet again, we did it with a roof coming off separately. The last case I want to talk about gets into a much more extreme case where we are locked down in many sort of angles. So we said, how can we make this work on this type of site? And we ended up with 3 different isolator rows, and even in the middle of our field, but because they're modular and flexible, we could do this. So we ended up with an isolator row at the bottom, on the tops, and then the QP system in the middle. Once again, we had a bypass manhole to handle some of the peak flows, get that out and into the other systems. Pre-treatment device on this was here, because this was handling roof runoff, not roof runoff, I'm sorry, parking lot runoff, and actually I think a parking garage. And then we had a maintenance manhole here, and I didn't actually highlight it, but we have a maintenance manhole here and here. So because we had isolator rows in these sections, we still provided a maintenance manhole for a way to get in and maintain these guys. We used steps in the systems so that the lower storms went into the isolator rows, and then the larger storms went into the peak management system. And lastly, seems to have happened in every case that we did. If we were able to put the roof runoff outside of these systems and just put it right into our peak system or into our water quality section, depending on what the site required, that's what we did. that was a very quick case study on that stuff. I'd like to give a big thank you to Chris and Aaron and Kyle for helping us through the ages of doing this and making this stuff. And I'll turn it back over to the panel.
Awesome. Thank you so much, Brian and Kyle and Chris and Aaron, for your presentations. We have plenty of time for questions, so please go ahead and type any questions you have into the questions box. I will go ahead and start reading out some of the ones we have here. So this, I think, is a question for Chris. Who is involved in the TRC? Is it only DEM program staff, or does it include outside members / professionals?
So this is, it's a purely state-ran program, so it's just DEM, DOT, and CRMC, although we have discussed the potential of maybe bringing in some outside consultants to expand our bandwidth and get some more expertise involved in the process. But yeah, right now it's just DEM, DOT, and CRMC. There's no outside involvement in the review process and the approval process. So, but like I said, that could change moving forward.
Thank you. There was a question for, I think, Kyle and Aaron. Are these systems designed for load limit, especially in a parking lot?
Yeah, I mean, not particularly. It's really going to come down to what the annual load is, what the application is. I mean, these are on parking lots, you know, all over New England, all over the country, all over the world. It's really going to come down to maintenance and focusing on, you know, Rhode Island 2 times a year. I always say, you know, inspect often, maintain as needed. So once you start monitoring the system, you see 1 inch to 3 inches of sediment buildup. That's when you certainly want to consider maintaining it. But to say, is there any quote unquote restriction? No.
Yeah, and also to add on to that, I think that based on the way that we are requiring the systems to be sized and maintained, you know, we size them for the water quality flow, and then we have them inspected twice annually. So, you know, I think that kind of takes care of the loading issue, as long as you're not, you know, like having a situation like Aaron showed where during an active construction site, they're letting the, you know, erosive flows get into the system. But if you just have once the site's stabilized, the size of the system and the frequency of the maintenance should address that concern.
And most sites do have treatment train built into it. I mean, you're going to have your offline heat sump catch basins, which, though they're not doing full TSS, they do get some removal at that, assuming that your owners are maintaining their catch basin sumps, are going to get removal there. As Brian had shown, you can still potentially include pre-treatment separators before systems if you want to go full belt and suspenders approach, but there are ways to keep, you know, doing removals along the way and having that treatment train.
Okay, great. We have a question from Kevin. Do the engineers and designers ever need to complete mounding of groundwater analysis when these systems are proposed in close proximity to property lines or buildings to determine if intrusion will be problematic?
So for around DEM, we have a list of horizontal setbacks for all infiltration practices, and that kind of has 2 tiers. There's the small residential applications and then pretty much everything else. So that kind of specifies how far away you're allowed to put these infiltration devices in hopes to avoid you know, seepage into adjacent neighbors' basements. But yeah, in terms of grounding, or I'm sorry, a groundwater mounding analysis, that's not really something we look at in terms of proximity to other structures or properties. It's more of separation to water table. So if you have a system that's handling the peak flows for the larger storms, and you have less than 4 feet of separation to the water table, then we'd require a groundwater mounding analysis. But in terms of separation to property lines or other structures, we have a table for those values. And also just to kind of add on to that, if the highest level of like water within that infiltration system is lower than the slab or basement elevation of the nearby buildings, then those requirements don't really apply for the horizontal separation.
I'd like to back up with Chris said too. We do look at that, and we follow the visiting requirements on the separations, and we have looked at sites. Actually, the first case study, we were kind of close to the building, so we did do a mounting analysis on that internally just to make sure that we weren't going to have any issues.
Chris, there was a follow-up to that, if whether that table could be provided. Is that something we could hand out to attendees after the webinar?
Yeah, I can forward that to the panelists, and they can send it out with the slides. But it's in the Rhode Island stormwater regulations, but it's buried in there, so I can take a snippet of that particular table and send it out so everybody can have access to it.
Perfect, thank you so much. There's a question about maintenance contractors and whether owners have found any difficulty finding them.
So in terms of maintenance contractors, I mean, they're all around throughout New England. Basically, anybody that's got a jet vac with a hose on the front, proper nozzles, they can do it. A good one regionally that I know of also is a company by the name of Stormwater Compliance. That's one that's routinely around, and I'm sure they're in the Rhode Island area because I know they service a lot of sites in Massachusetts.
Yes, we are actually working with them on a maintenance training series that we have coming up as well. So I do know that they do some work in Rhode Island. Okay, so I don't see any additional questions in the question box, but we did receive some questions ahead of time prior to the webinar, so I'll ask some of those. There was a question about the isolator rows and whether they are intended to function as pre-treatment or whether they provide nutrient reduction as well.
Yes, so that's going to be kind of state by state and reviewer by reviewer, so to speak. As I showed at the start, the UNH testing that was done at the Stormwater Center back in 2008, that did have some information on that, but it's really going to come down to, you know, the testing protocols that each one of these BMPs go through, and then what the state looks at, wants to accept for data, and so on and so forth. And I'm sure Chris could provide feedback on Rhode Island's take.
Yeah, so for the Rhode Island approval, we are only certifying this for TSS removal. So like Aaron said, some of the studies did indicate that there is some metals and nutrient removal, but our certification, we're only giving it credit for TSS. So if you were doing like a treatment training for a pollutant loading analysis on a site that discharged to a water body that had a TMDL, you wouldn't get any credit for the either of these pre-treatment rows for you know, like nutrient removal or bacteria removal either. That would be more along the lines of a one of those water quality BMPs like I had spoken of before. The requirements for those are a little bit more stringent. So I hope that answers the question.
Okay, there was a question about whether the Cultec technology could be used in a residential backyard, and if so, how far away from a basement or foundation should it be installed?
Yeah, we are used in residential applications all the time. Very common in New England. For proximity to buildings, our recommendation is at least 10 feet away from any structures. If you need to be closer, I would recommend reaching out to us directly to help you design a solution that would work. We do have a few special design parameters that we can implement when we're within 10 feet. Absolute closest we would go is 5 feet. But again, you'd have to reach out to us for that special design scenario.
Okay, thank you, Kyle. And the last question that we had received in advance was, how can my organization help towns implement these new technologies? So that's kind of a question for everyone, I suppose.
I guess first and foremost, to implement it, design with chamber systems. That's really what it comes down to. If you design with chamber systems, you can absolutely implement separator row, isolator row plus. You can build it right into your stormwater system. Everybody in the presentation saw how easy they are to install and construct, and then how effective they are in terms of their performance. So it's really to use them, just design and specify with them.
Yeah, and also too, I think that maybe trying to market them as like a sort of like a retrofit might be useful because, you know, like I was saying in my presentation, if you have these sites where, you know, there's either no stormwater management at all, or the existing systems are just completely blown out and really doing nothing, you could use one of these systems, but still maintain, like, say, a parking lot or, you know, some impervious cover. So they're really good in the urban areas where, you know, building space is very limited. So you could market it in that way. And also, you know, just kind of advocating that, like, the maintenance is the most important part. And, you know, these pretreatment devices help protect the full system. So like Brian was saying, you know, if you want to reduce flooding problems and, you know, improve water quality, these pretreatment systems really go a long way. So, you know, I think that might be a solid argument to make to people making these sort of decisions. But I don't know if you're looking for more of like a funding type answer. So if anyone else has any knowledge on that, feel free to speak up.
Okay. Well, I am not seeing any new questions coming through on the question box here, and that we've gotten around to all of our questions that were asked beforehand. So it looks like we're going to have an early end. But on behalf of the Stormwater Innovation Center and the STEP Network, we really thank you all for attending. We encourage you to fill out the post survey that will be going out, as well as checking back on our website for full bios of our presenters and a recording of this webinar that you can refer back to. So thank you all for attending, and I hope you have a wonderful day.